Hello YouTube, this is Stan from Stanny G Tech, and today I'm gonna present to you something that's called Mechanics of Object-Oriented Programming. Pretty much I talked about it in my first video on this channel, and that was based on .NET language called C Sharp. Now, I was asked by my friend to help him to understand that in Java. So pretty much, as I said back then, and I'm making the video for my friend. Pretty much in programming, in object-oriented programming, you deal with objects. So everything revolves around objects. An object, as we know already, has properties, has methods. So you take object, for example, your cell phone, right? Cell phone has properties. Like what kind of cell phone is it? Is it a flip phone? Is it like a smartphone? What color is it? What material is made of? And then it has methods. Well, what kind of methods could you think about cell phone? Well, functions, right? Can you make a call? Of course you can. But besides a call, what can it do? Can it go online? Can you play games on it and so forth, right? So, knowing that, let's talk about actual mechanics, what happens and how to understand. I spend quite a lot of time trying to understand how this all works. Like I tried to study the commands when I was trying to program first. I was trying to study, okay, so you first do this command, then do that command, then do that command. But it comes really hard when you have to actually code yourself and write your application on your own. So you need to understand mechanics, and once you understand the mechanics, any program will come easy. There will be some technical difficulties, I should say, some challenges, but it's something that you can work through knowing how does the computer handle all this. So as I said in my first ever, I should say, a lecture, tutorial, computer has a lot of components, but the main components that we're going to talk about is memory and processor. So the way the programming works, you store stuff in memory. So you, the human being, store stuff in memory. Then the processor, when it works with the data, with the whatever, when the processor works with your information, it gets it out of memory, processes it according to your request, and then puts it back into memory to store it, right? So let's look at the pretty much how does it work. That's why I have a paint brought up. So memory, as we know, it has cells. So everything is stored in memory cells. So by cells, you can imagine little boxes or containers, right? They're all different size and shape. Could be this, could be that, could be this, depending what you're working with, right? So every container has its purpose. So this one can store one thing. This one can store another thing that is long, for example, long and slim, right? This one stores something that's not too long, but it's huge, right, in size. This one is even huger, right? So pretend you have a set of containers, plastic containers at home, right? Well, that's the way to think about it. Pretend you have a plastic containers, and you probably understand that in home everything has to be organized. Like you have to organize your paperwork, you have to organize your tools, you have to organize your whatever miscellaneous that you have, like screws, nails, whatever. And you can't just put it into one container. It will be harder to find. And even if it's harder to find for us, imagine how it is for the computer, right? So for this, we title each container. So we put, let's say, screws in a container. So we put little screws, right? Little tiny screws for the container, and we title it screws. We put, let's say, tools such as hammer, screwdrivers, wrenches, all that stuff. We put into, let's say, this container, right? And we call this container tools. For example, tools. Maybe specifically which tools are these, right? We put, let's say, paperwork in this container, right? We put it in this container, and we call it paperwork. If needed, we can create another container. We can create different containers. Let's say this one contains music sheets. This one contains school stuff, or like, I don't know, some loose leaves, texts, whatever, math, whatever, right? This container pretend contains something else. So, but again, the problem is when you pile these containers, you would need to find a container that has school stuff, and if two containers are looking the same, right, without a special notation on the container, without the special label, it will be kind of hard. Pretend you have multiples of these containers, right? So it'd be kind of hard to find. So what you do is you write on the container, what you store. For example, this is going to be your school stuff. This is going to be your, I don't know, work stuff, maybe some manuals for something, right? It could be another container you can store the same type of the container. I can store, let's say, letters, I don't know, whatever else, bills, whatever else you want to do, right? So, for this purpose, what you do, you title each container. So, this is work stuff, this is school stuff, this is letters or bills. These are tools, these are screws, these are something else, whatever I said, right? Now, in a computer memory, since the computers are dumb, they don't understand okay, so those are just called tools, those are just called schoolwork, these are just called something else. The computer would not figure out what you put inside the container. So you need to give a type to each container. Like you need to say, okay, metal tools, all right? You need to say metal screws. You need to say paper, school paperwork, paper, work documents, manuals, whatever, paper, something else. So you need to give it a type so that the computer will pull out the right information from the right container and treat it correctly. So for these, we have something that's called data types. Now, data types could be different, and you probably can go into my first video and see it's the same thing for object-oriented programming. For all languages, it's pretty much the same. They could be integers for math, for example. Integers, right? Doubles, floats, which are pretty much the same thing, only floats has, I think, slightly kind of like, it can hold bigger decimals. We have chars, which holds the character. So let's say you want to count how many characters are in the word, how many letters are in the word, right? So you're gonna go by character counting character by character, right? And you can have text, which is a string, right? So all those containers pretty much have their own size. So why do you want to specify for the computer which kind of container you're putting your stuff in? Because the computer would know, oh, okay, it's integer or it's double, it's math related. Okay, I can use the operation and add them and calculate them, because there are, in Java especially, there are classes already pre-written in the library that do all those operations. You don't have to explain to the computer what is plus, what is negative, what is minus, what is divided by, what is times. You don't have multiplication, division. You don't have to addition, subtraction, we should say that way, right? Addition, subtraction, multiplication, division, raising into a power, taking the derivative, whatever else it might be. There's a math class inside the application already pre-written, so you can use it, but then you would have to store stuff in the right containers for it to take it and use it, right? So when you store integer in a container of integer, it knows, okay, that's math related. Okay, I have to do some operations. But when you store the integer in a text container, in string container, it treats it as a string. So when you, for example, say pull out number one, you say store number one in a string container, and store number two in a string container, and you do the operation 1 plus 2, what's going to happen? So you add two strings together. So if you add two strings together, 1 plus 2 is going to be 12, right? 1, 2 is going to type 1, 2 pretty much. So you add two strings, two letters together. A and another letter A is going to be AA, right? But if you add it to the right container, then the computer will know, okay, here's what I'm using in my math class, and that's where I'm adding 1 plus 2. According to math class, it's an operation with digits, with numbers. Okay, 1 plus 2 is 3. Okay, I'm going to give out 3 as an answer. All right, so the containers and, data type is really important. So when you want to create an object, you always want to give it a data type. What type of object is that object? If it's a integer, you want to say integer number or integer digit or whatever. You can give it whatever name you want. You can say integer amount of pens I have, or amount of books I have, or speed of a car, something like this. You can give it whatever name you want, so you can refer to it inside your program, so you understand what it is. But you have to give it a data type. So that's also important to understand. Now, knowing the container principle and data type principle, pretty much you can write any program you want. Now, let's say in our first program, which older programmers do, it's called Hello World, right? Pretty much it involves printing out a string of text, right, on the computer screen. So how do you do this? So for this, I'm not sure which program does my friend use, but I use NetBeans. So in the NetBeans, I'm not sure if you're aware of a NetBeans, but it's pretty much the same thing. You have, you install NetBeans from the website, right? You Google NetBeans and you install it. But now you need to create a project in NetBeans. So this is, title bar. This is tools, right? You see the play button, which runs the application. You see probably a stop button that stops the application. You might see other buttons here, but we can talk about this later. But let's create a new project. So you click on File, and then you go to New Project. So now in this window, it asks what kind of project, what type of project you want to create. So let's create a Java application, because we're creating the application. So you will leave it like this, right? And you click Next. Now you give your project a name. So let's say name would be First App. You can give it whatever name you want, right? And you notice that it creates something that's called the main class. Now, main class is basically the main area where you're gonna build your application. So you click on Finish, and it's gonna create the application. It's gonna pre-write some stuff in there, right? So package, which is like a folder. Pretend you're creating a folder, right? And you're saying, okay, this folder is gonna contain my pictures. Okay, folder pictures, right? So package is gonna be called First App. A public class is going to be called First App. Class is an object. So it's like a field where you're actually building the application. Now, what you need to do for this application is pretty simple. You see it says public static void main string args. So this is just, we can talk about this, what that means later. But what you need to do, you need to realize something. You need to kind of think. All right, there are two different ways to do this application. You can use, I clicked on insert, I think. Yes, there you go. First thing, you can use already existing system in the Java class library. There is a printer. So you can print something on the computer screen. Dumbly, just type whatever you want it to print, and it'll print it for you. All right, the way that works, so pretty much, you tell it to output some string of text, and you in this application, we're not going to create a container. We're just going to ask the computer, hey computer, please type whatever I type in. in this printer. Whatever I give to this printer class, please just blow it on the screen, right? Okay, so to do this, there's a command to type. So first I gotta refer to system, right? So I'm talking to a system. So I'm talking to a computer. I say computer. Okay, so I type the word system. That's a keyword. System. In Java, this is a keyword, right? System. Then I put a dot because I want to tell the system what I want to do, right? System. All right, system. Next command. Now I need to think, okay, I need to print it out on a computer screen. So what's my next word? And it's actually, there's a clue in here. What's the next word would be print it out on the computer screen. So the next word would be out, right? So system dot out, then give it a dot. And now what do I want to do? I want to print. Now, here's the thing. There is a print ln command, which is right in somewhere here. Print ln, right? Print ln. And there's a print. There's a print f. So if you want to format something when you print, like imagine you're printing a document and you want to format, give it certain format, so it prints out not just line by line by line by line, but you want to, just be nicely displayed on the screen. But normally you print a line. In this case, we print a line, right? We can do print, just print. It will still print. But print line, you're specifying that you want to print a line of text, right? So you choose print ln, right, like this, and it gives you this format, right? System.out.println. You can type it out. You don't have to. If you know how to type it in, you don't have to use those things. Select some programs do not provide, some IDEs or programs that you write programs in, they don't provide the clues, right, the hints. So you need to know this. That system, you're referring to the system, to the computer. Out, you showing that you're gonna do the output from the keyboard. And print ln, pretty much you say, hey, just print a line for me. Now in parentheses, straightforward, you want to print a line of text, right? You can print objects, and now we'll talk about this in a little bit. But what you can do also, you can print a line of text. Whatever you type in, you can type in whatever. Like, look. Now, if you want the text, you need to put it in quotes, right? Because you're quoting. Okay, I want you to print exactly that. And you can type whatever. It'll print exactly that. But for the showing purposes, we'll type in hello world. Put the exclamation mark, right? Hello world, right? So that's your first program. Now, when you run the application, which is this play button here, you push it, and voila, look, it printed out hello world and showed you that it did it successfully in no seconds, right? Now, that's the first step. That's the first type of writing this application. Normally telling the computer what to print. Print, I don't know, whatever else you want to print. I like Minecraft. I like Minecraft. You don't want that to happen, right? Now, I like Minecraft. And let's see if it's gonna print it. Huh, I like Minecraft. Look at that. Now, whatever is type here, the parentheses, the semicolon, in each language is different. These are called syntaxes. So in each language, you have to learn the syntax. How do you write a function? How do you properly, give a computer to know that, okay, this particular language is typed this way, and this is what you need to do. All right, so now let's do the second type of this application, hello world. Now we're gonna use containers. So pretty much, what you want to do is you want to create think about it, what you want to do based on what I've talked about in the Paint application, right? You want to put a text in a container. So you want to store an object. You want to store it in the memory. So what data type refers to text, as we were talking before? String, right? String of text. You want to hold the string of text in memory and then pull it out whenever you need it, right? So for this, we create an object in its own container, and we call the container, and we give it a type, right? We give it a type string. String, you give it a space, and then you type in whatever. You can write whatever you want. Hello, right? And you want to put the semicolon in there. Now string, it does that because you can actually, when you write something wrong, you can just go like this, and it'll find it. So cannot find symbol class string located class first app. Now you can alt enter and it shows hint. So let's do this. Alt enter and show hint, right? Oh, what did I do? I broke it. Alright. String. Alright. String. Okay, so now alt enter. Create a class called string. You don't want that. Create a configure United untitled element. So what you want to do in here, right? What you want to do in here is you want to make sure that the string is with a capital S, and there you have it. Because you have to know how does computer know that this is a, this is a string. So you put it in the capital and see how it is here, string. So you wanna put the string. That's the command that computer knows. Ah, string. You mean string? Okay. You mean string of text? Okay. So string hello. Now you can just store a string hello empty string. That's gonna be the empty string. You can specify the empty string like this. String hello, set it equal to nothing. That's gonna be nothing right here. That's gonna mean nothing, right? You can set the string hello to hello world. You can set the string hello to contain the whole text file, and then later on print it out whatever is in the text file. So you can store just store a hello world store a hello world for our purposes. So we created an object of type string called hello. So container, right? Type string called hello, and we said okay, the container that holds a string named hello would contain text hello world. All right, what do you then do next? You're pretty much printing it out, right? So you say system dot out dot print. You can print a line because it's gonna print line. Now, in the parentheses, since you're printing the contents of the object hello, right? The container hello. You're printing the context. You're not printing hello world. You're not printing this string. You're printing this one. You're printing hello, right? So how do you refer? You say to the computer, okay, system, please print out whatever is in the container named hello. So since you're not printing the exact string, you can just refer to a container, right? So you can do hello. Type it exactly as you type it. And now look what happens. When I push play, it's gonna print hello world. Now, why is it printing hello world? Because it says, so I need to look what's in hello and print it out on the screen. Okay, so what's in hello? Hello equals hello world. Okay, I'm just gonna print out whatever is in hello, and then hello contains hello world. So that's pretty much the different. There's no difference how the command runs, but that way you store it and refer to it whenever you need in the program, so that it makes the coding a little bit easier. You don't have to say, okay, system.out.string print line hello world, system.out.string print line. Today I'm going to talk about the economics in the world. System.out.string, you don't have to do this. All you can do is create one object, which is a container, right? Refer to a box, refer to a container, and tell computer whatever is in the box. I don't care whatever is in that box. Just print it out on the screen. It could be this. Doesn't really matter, right? So when you print this, it doesn't. It prints whatever it is in hello. So again, why do we need containers and data type? All right. So another question: why do you need containers and data type? It keeps things organized. So imagine tools laying around. Imagine everything is laying around on that, on that paint picture. Imagine everything is laying around on a table or on a desk. Papers mixed with screws, mixed with tools, mixed with you have hard time kind of to separate everything. So you want to keep things organized, right? Especially knowing that you're using computer memory, and the computer memory is not infinite, so you want to kind of keep things organized nicely for the computer to faster run your program and for memory to be used more efficiently. So that's what you do with the containers, and that's what you do with how do you define a container, how do you define an object, and how do you or declare an object. So basically, declaring an object, something that's referred to declare an object or declare whatever variable, right? That's what it is. You let the computer know, okay, what do you want the variable or object to be, right? And then in what is its data type? What do you want the computer to do with it? What type? Okay, computer basically says, okay, I deal with math objects differently than I deal with text objects. So tell me what data type of the object that you want to create, right? So that's the first class. Hopefully it was informative, and hopefully you can create a program, Hello World, and know now how to, how to print out a string of text. In the next section, we're going to talk about something more advanced. Pretty much, I'm going to be talking about a little bit about concatenation, something that's called concatenation. Pretty much, it's when you print out a line or print out something on the screen. You want to, let's say, use mix of containers or of objects that you created with a string. So, for example, writing a program like hello, and then using person's name, have person enter the name on the keyboard, and then you say my name is. You let the person enter their name, and then I am from, and having the person enter where are they from. For example, this way. Or, my name is this, this, and this, and I am this and this and this years old. Something like this, So how do you actually do it? How do you use a mix of a string and objects inside the print ln statement or print statement? Until next time, thanks for watching, guys, and as always, subscribe, comment what you want to see next in my videos, and make sure to click that notification bell so you don't skip my other videos, and hopefully that will help my friend. So please let me know. You know who you are. Please let me know, if that helped. And if that helped, I'll know and continue with more classes. Thank you, guys. Until next time, this was SJ Solar Reviews. I was going to say. This was Steny G Tech, and I'll see you next time. Bye-bye.